Morning, everyone. We're going to be continuing our conversation on productivity today. Again, it's the productivity piece isn't directly relating to your creature, but it's going to help you understand why your creature eats where it does and what it eats, and understand what it eats. So today we're going to talk about the variations in productivity. Remember that productivity means that anything that makes its own food. So the amount of creatures or organisms that are making their own food dictate how productive that area is. And that's using either photosynthesis or chemosynthesis. So we have regional variations in productivity, and this basically has to do with how nutrients are unevenly distributed, and then also how sunlight is unevenly distributed. So in different regions, you may have a different availability of nutrients or a different availability of sunlight. And so that's going to affect the productivity that you're able to see in that area. So depending on whether that makes it highly productive or less productive, you might see that your creature would go to eat there if it was highly productive or would not go to eat there. So it is more about what is drawing in the other creatures. That's kind of what I want you to be hearing. So there's certain areas where we can expect to find a high diversity of other creatures simply because it's highly productive area. 90% of the biomass from the euphotic zone decomposes before descending. And so that also plays into our organisms that are detritus feeders, because you are not having that photosynthetic food source. So if 90% of your photosynthetic food source decomposes before descending, then that isn't part of your food source. So your detritus eaters or your scavengers, those are almost exclusively meat eaters because that they're not going to have that food source. Also, what that tells you is that outside of the euphotic zone, you're not getting any photosynthetic food really, if 90% of it decomposes before going down into the depths. So these are just some different ecosystems and where that productivity comes from. So you can see in our oceanic ecosystems, we have algae beds and coral reefs, estuaries, upwelling zones, continental shelves, and the open ocean. You can see what the average level of productivity is for each of these. So our most productive areas are our algae beds and our coral reefs. So that explains why we get so much diversity of life around a coral reef, is because it's a really highly productive area, and the photosynthetic food that makes up the basis of every food web is highly available in that area. Estuaries are close behind, and upwelling zones, even though they're far behind estuaries, that's still a pretty high level of productivity. And look, it can go all the way up to about 1,000. So continental shelves are pretty productive, but there's a lot of interfering factors there. But if you look here in the open ocean, if your creature lives exclusively in the open ocean, they probably are migratory. And with them being migratory, they're going to have different areas where they're going to go to get their food and then go back out into the open ocean. There's not much productivity that occurs in the open ocean. So we only have about 1% of organic matter that's not decomposed in the open ocean. And this is something that we see in looking at what's called the biological pump. And so the biological pump is moving material from the euphotic zone to the seafloor. And what is pumped is CO2 and nutrients. And so you are able to look at the levels of nutrients in the area in the past and the levels of CO2 in the area in the past, because that gets captured in the sediment. And so then You have your subtropical gyres and the thermoclines and pycnoclines that are associated with them, preventing the resupply of nutrients to the surface. So this is where upwelling becomes so important, because in that gyre, that spinning of things is part of what helps cycle everything down to the sea floor. So if all of your nutrients are getting, and CO2 are getting pushed down to the seafloor, this is where upwelling becomes so important, because that's what the photosynthetic food needs, or photosynthetic organism need in order to survive. So here you have your productivity based on region. Your most highly productive areas are your polar areas. And most people wouldn't think that, because we don't think about there being a lot of life in the polar areas because it's so cold. But in the summer times, this is when we get huge migration toward the polar areas, because remember that increased nutrient availability goes with cold water. Well, if the water is pretty much cold all the time, you're going to have increased nutrient availability. Now, here you would think that your temperate or middle latitude would be second place after the polar oceans, because their ocean temperature is just a little bit warmer, not much. But we see that they're actually in third place. And that's because if you think about what happens here, you have a gyre, a north gyre and a south gyre in each of these middle latitude areas. And so remember that gyre pushes everything down toward the seafloor. Now, our tropical oceans come in second place, even with the warmth, because of upwelling. Remember, all along the west coast of the continents, we get these huge areas of upwelling because of the direction the currents are going. So they come in second place because of that feature of upwelling. So when we look at the polar oceans specifically, we have complete darkness in winter. And so that doesn't help our phytoplankton bloom, and doesn't help draw in our zooplankton either. But then you have all this sunlight in the summertime. And so what you see in the polar areas is you see a huge bloom right about May, in the late spring, of your photosynthetic plankton, so your phytoplankton, and then your zooplankton follows right after it with its peak, because your zooplankton are eating your phytoplankton. So the phytoplankton has to be there first. And so for example, in the Barents Sea, that's what this productivity graph is based on. This is what we see across the Arctic. In your Antarctic areas, remember that Antarctica is a continent. So not only do we have the same type of scenario with sunlight as we do in the Arctic, but now we've also added the characteristic of upwelling. So in Antarctica, it's incredibly productive once you hit springtime, because of having that upwelling, in addition to being, having all that sunlight available all of a sudden. Now, remember that there is still, but it's less so now, there was a very large hole in the ozone layer over Antarctica, and it does vary in size from year to year. But what we noticed when that phenomenon was starting to be discovered is that there was an unexplained decrease in productivity in that area. So nothing had changed regarding the sunlight that it was getting, nothing had changed regarding the upwelling, nothing had changed regarding those normal systems that we were aware of. And that led people to start looking at atmospheric possibilities, which is when we stumbled upon the ozone hole. And so basically, extra UV radiation was being allowed in because the ozone layer wasn't there over that location to be able to absorb that. And it caused your productivity to decrease because it basically mutated and modified the phytoplankton to not produce. Now, the other thing about the polar areas is that they're basically isothermal, so there's little mixing. We don't have a thermocline, it's pretty much the same top to bottom. And so that means that your plankton remain at the surface, which makes them really easy to get by whales and other fish and other zooplankton that feed on them. Blue whales in particular, so if you are doing some kind of a whale, make sure that you include information on migration because this and breeding are what determine their migration. So that's why we're talking about these variations. Other fish that migrate, like salmon and other things, you need to pay attention to whether or not your creature migrates because this is lying underneath all of that reason. In our tropical areas, we have this really steep thermocline. So it's really warm at the surface, and then at a certain depth, it drops off really suddenly. And then now we have this cold nutrient water that's trapped. And so with that, you have that permanent thermocline, and that acts as like a barrier or a wall between your surface water and then your cold nutrient rich water. And so this lowers the productivity of the area, except we get that upwelling in those certain areas. So that helps out in the tropical areas. In our areas of upwelling are so you have your equatorial upwelling that just happens due to currents, and then your coastal upwelling when it runs into land. You also have coral reefs in the tropical oceans, which helps recycle nutrients, and they also are symbiotic with algae, so that helps the productivity levels in the tropical ocean. In your temperate oceans, you have lack of availability to sunlight because we're not getting direct sunlight most of the time, and then available nutrients as well is difficult. So you see this seasonal, like highly seasonal pattern. So winter obviously is going to be low productivity, and spring is very high because you get your spring bloom when your sunlight comes back of phytoplankton. And then the summer is really low because you get a really strong thermocline, so it kind of walls off that cold water. And then you'll get a bloom again, less so in the fall because the water temperatures are declining. So in the temperate oceans, you see this big peak again in the spring, and then a smaller peak in the fall when the sunlight is passing over that area. So that also, so here, if you look in the winter, we don't have a thermocline, which is great because we don't have mixing, but we don't have the sunlight available. In the spring, we have a very weak thermocline and we have the sunlight, so that allows for that bloom. In the summer, we have that really strong thermocline, so we don't get nutrients, even though we have the sunlight. And then that thermocline weakens again in the fall, and we've got decent sunlight still, so we can increase our productivity there. And here's what that looks like on the graph that we looked at from the polar region too. So you have your spike in the spring, and then just a smaller spike in the fall. And that's it for that.